Hello everyone, welcome back to the iRender tutorial series, triply periodic minimal surfaces, also known as TPMS, are special geometric structures defined by surfaces with zero mean curvature at every point and repeating periodically in all three spatial directions. Thanks to their high surface area, lightweight properties, and strong mechanical performance, TPMS structures are widely used in engineering and material science applications such as 3D printing, biomedical design, energy absorption, heat exchange, and more. There are many different types of TPMS structures, with some of the most common being the gyroid G structure, known for its spiral form and high strength, the primitive P structure, and the diamond D structure, which has a diamond-like pattern. In today's tutorial, we'll explore how to simulate these fascinating TPMS structures inside Cinema 4D using scene nodes and volume workflows. Let's get started. We'll begin by creating a boundary using a connect object to keep the setup flexible for later adjustments. Inside the connect object, create a platonic object, set the radius to around 150 centimeters, and change the type to hexa. This gives us a cubic spatial boundary for the TPMS structure. First, we use node mesh and create an object link input in the node workspace. Then, we apply volume voxel fill to turn the object into a solid volume and set up several control parameters. Next, we use the decompose container and iterate collection nodes to extract the point coordinates from the solid volume. Using the split vector node, we can access the X, Y, and Z values in 3D space. Don't forget to use the boundary object created earlier in the object link node. Once we have the X, Y, and Z coordinates, we apply the mathematical formula, shown on screen, to generate the TPMS structure. Here, the L parameter defines the size of the unit cell in each dimension, while the T parameter controls the thickness of the structure. We use calculation nodes together with the trigonometry node to implement the formula inside the node environment. Next, the assemble collection node is used to collect the original point coordinate data along with the points processed by the formula and calculate the result using the t parameter. Then, we use the append element node to build the final point collection. And the point set node outputs the final result. For visualization, we use Volume Builder with the volume type set to fog. We use Espresso to synchronize the voxel size of the node mesh with both the voxel size and mesh point radius in the Volume Builder. At this stage, we notice a mistake in the calculation logic related to parameter t, so let's correct it before moving forward. Now we already have the preliminary structure of a gyroid, one of the most well-known TPMS structures. To get the gyroid surface, we add the original connect boundary object into the volume builder and change the node mesh mode to divide. Then we apply a fog smooth modifier with a strength of around 50%. As a result, we obtain a smooth gyroid iso surface. Changing the parameters will produce different results within different spatial boundaries. By applying the same workflow with different formulas, we can generate other TPMS structures as well, such as the primitive and diamond surfaces. Thus, we've completed the simulation of TPMS structures in Cinema 4D using scene nodes and volume. By combining mathematical formulas, procedural node setups, and volumetric processing, we were able to generate complex structures such as gyroid, primitive, and diamond surfaces inside a fully flexible system. We hope this tutorial was helpful and gave you new ideas for your own procedural experiments and creative explorations. and if your current setup is holding you back. Remember, iRender Render Farm provides powerful workstations from single to 8 RTX 4090, so you can choose exactly what matches your project needs and budget. If you enjoyed the video, don't forget to like, subscribe, and stay tuned for more tutorials coming your way. Thanks for watching, and as always, happy rendering, happy creating with iRender.